Hi, welcome to this lesson on calculus derivative laws. Let's have a look at question 4. If we are now given that the function f of x is 2x cubed minus x squared minus 2, then we want to find the values of x on that function that give us a first derivative equals to 0. So here's my function f of x. It is composed of sums and differences. So I can use my derivative laws. So the derivative of f with respect to x, so f prime x, is equal to the derivative of 2x cubed minus the derivative of x squared minus the derivative of 2. Okay, so now I can use the power law here, bring the 3 down, so 2 times 3 times x to the power 3 minus 1, minus, bring the exponent down for the power law, so 2 times x to the 2 minus 1, minus the constant law, derivative of a constant is just 0. So let's clean that up. 2 times 3 is 6, x to the power 2, minus 2 times x to the power 1. All right, so that is the derivative function for the original function. But we want to know, when is this thing equals to 0? We want to find the x values. So therefore, we are solving the equation 6x squared minus 2x equals 0. So this is a quadratic equation we can solve. We pull out a common factor of 2x. And I'm left with 3x minus 1 equals 0. So now I've got two factors being multiplied. I can use the 0 property of algebra. When I have products, that means 2x must equal 0, or 3x minus 1 must equal 0. So in this case, I have x equals 0, or I have x equals 1/3 after solving 3x minus 1 equals 0. Okay, so logically, what does this mean? Well, this is a cubic function, so we're still going to learn how to draw the cubic functions. But essentially, at the point x equals 0, if I plug that in, I'm going to get negative 2 here. So 0 and negative 2. And if I plug in 1/3 here, let's just see what that gives us, right? 2 times 1/3 cubed, right? Minus 1/3 squared. So I'm just substituting these x values back into the original function, and I get negative, let's say negative 2.04 if I approximate. All right, let's just check. Yeah. Okay, so that's at x equals 1/3, which is here, and then that's going to be here. So at x equals 1/3, I have negative 2.04 if I round off. Okay, what it just means is that depending on what this graph looks like, what's going to happen here at these points is that when we look at the tangent lines at that point, the gradient is going to be 0. That's what the derivative of 0 means. The gradient of that tangent line is going to be 0 at those 2 points. Okay, and we'll have a better look at that when we sketch cubic functions. All right, so that's how we would do this type of question. I'll see you in the next one.